Hello friends, myself R.D. Mahajan presenting my video on Gauss's forward interpolation formula. Earlier I have discussed Newton's forward and Newton's backward interpolation formula. Uh, in this I will discuss this Gauss forward interpolation formula. If we require to obtain the value of f of x for some x which lies in the middle of the table, if it lies in the middle of the table, then we have to apply this central differences formula. The first one is Gauss forward interpolation formula. For that we make a forward difference table as I had discussed in my earlier video. Values of x are, middle value we call as x0 y0. Below it we have x1 y1, x2 y2, and above that value we have x minus 1 corresponding y minus 1, x minus 2 and y minus 2. Means the values of x are x0, x1, x2, x minus 1, x minus 2, and the corresponding values are y0, y1, y2, y minus 1 and y minus 2. Positive suffix below the value of y0 and negative suffix for the values above the central value. Then we find the first forward differences as y minus 1 minus y minus 2, that is nothing but del y minus 2. Then y0 minus y minus 1 is del y minus 1, y1 minus y0 as del y0, y2 minus y1 as del y1. Therefore, this is the column of first forward difference. If we take the differences of these differences, we get second order differences as del y minus 1 minus del y minus 2 as del square y minus 2. This del y0 minus del y minus 1 as del square y minus 1. Then del y1 minus del y0 as del square y0. This is the second order forward differences. Differences of this we get third order differences as del square y minus 1 minus del square y minus 2 is nothing but del cube y minus 2. Del square y0 minus del square y minus 1 as del cube y minus 1. And differences of these differences we get fourth order difference as del cube y minus 1 minus del cube y minus 2 is del raised to 4 y minus 2. We draw a central line x0 y0 del square y minus 1 and del raised to 4 y minus 2, and then we underline the values as I have made it in red colors. Y0, then del y0, then going this way we get del square y minus 1, again coming downwards we get del cube y minus 1, again upwards we get del raised to 4 y minus 2. Therefore we use these values to develop that Gauss forward interpolation formula x0 y0 del y0 del square y minus 1 del cube y minus 1 and del raised to 4 y minus 2, where the value of p remains the same as we are using for Newton's forward interpolation formula. P is given by x minus x0 by h. Then that Gauss forward interpolation formula, we have to make a slight change in that Newton's forward interpolation formula. Therefore, all of you are knowing that Newton's forward interpolation formula. Therefore, y of x is equal to, first term remains as it is y0, then p into del y0, then p minus 1 by 2 factorial, next second order difference, that is del square y minus 1, Therefore, this is as per that Newton's forward interpolation formula. Then p minus 1, that we have to multiply it here by p plus 1. This is the additional term in Gauss' forward interpolation formula. I have written it in blue color. Therefore, this is the new term we have to introduce. P minus 1 multiplied by p plus 1 by 3 factorial into this del cube y minus 1 plus this p plus 1 we keep as it is. The next p minus 1, p minus 2 divided by 4 factorial multiplied by 4th order forward difference of y minus 2 del raised to 4 y minus 2 and so on. Therefore, whatever this result I have written, that result is called as Gauss's forward interpolation formula. Therefore, once again I will repeat that step. We have to underline x0, y0, then del y0, first forward difference, then going upward we get del square y minus 1, coming downward we get del cube y minus 1, again upward del raised to 4 y minus 2, or the values on that central line and below that central line, a zigzag way. y0 delta y0 del square y minus 1 del cube y minus 1 and del raised to 4 y minus 2. Therefore, this is that formula of Gauss's forward interpolation formula. Then we try to see the simple example on it. For the given data, find population in the year 1992 using Gauss's forward interpolation formula. We have the table. First column of X, year, represent year, 1970, 1980, 1990, 2000 and 2010. Difference of 10 each and equispaced, therefore we can use Gauss's forward interpolation formula. Corresponding population in lakhs, 20, 25, 28, 34 and 39. Then making that forward difference table, we require to find population in the year 1992 which lies somewhere between 1990 and 2000, middle of that table values, and therefore we call this as x0. 1990 we call as x0. Corresponding y0 is 28. Below we have x1, x2, above minus x1, x minus 1, x minus 2, and the corresponding values are y minus 1 and y minus 2. And then making a forward difference table, we first find out this y minus 1 minus y minus 2 as del y minus 2 is equals to 25 minus 20, we get that as 5. Okay, next y0 minus y minus 1 is del y minus 1, and that is equals to 28 minus 25, we get 3. Next, y1 minus y0 is del y0, and that is 34 minus 28, we get that value as 6. Next, y2 minus y1 is del y1, and that is equals to 39 minus 34, we get that value as 5. The values are 5, 3, 6, 5. First forward difference, then differences of these differences, we get del y minus 1 minus del y minus 2 as del square y minus 2 as 3 minus 5. 3 minus 5 we get minus 2. Next, del y0 minus del y minus 1 as del square y minus 1, and that is equals to 6 minus 3, we get 3. Next, del y1 minus del y0 is del square y0, and that is equals to 5 minus 6, we get minus 1. This is the third forward difference. Second forward differences. Differences of this, we get third order differences as del square y minus 1 minus del square y minus 2 as del cube y minus 2 as 3 minus minus 2, we get 5. Next, del square y0 minus del square y minus 1 as del cube y minus 1, and that is equals to minus 1 minus 3, we get minus 4. This is the third order forward difference. Differences of this, we get fourth order difference as del cube y minus 1 minus del cube y minus 2 as del raised to 4 y minus 2, and that is equals to minus 9. Then central value is x0, y0. We make this central line. Then we consider the values below that central line. Therefore, x0 corresponding y0, then we make this way, that is del y0 is 6. Then we go upward, we consider this del square y minus 1, value is 3. Then we come below it, it is del cube y minus 1, that value is minus 4. And once again we go upward direction, it is del raised to 4 y minus 2, value is minus 9. Therefore, like this, y0, del square y minus 1, del cube y minus 1, and then del raised to 4 y minus 2, where the value of p is given by, it is x minus x0 by h. X, where we require to find the population, that is year 1992, minus x0, we consider this value as x0 as 1990, and divided by h, difference between that values is 10. Therefore, it is 2 by 10, we get that value as 0.2. And then applying using Gauss's forward difference Gauss's forward interpolation formula. We have, I will write down that formula first. Y of x is equal to y0 plus p into delta y0. Next one is p minus 1 divided by 2 factorial del square y minus 1 plus p plus 1 p minus 1 divided by 3 factorial y minus 1, this one. Next one is p plus 1 p minus 1 p minus 2 divided by 4 factorial into this value, that is del raised to 4 y minus 2, and then substituting the values we get y at 1992 is equals to y0. The value of y0 is 28. P is 0.2 into del y0 is 6 plus P is 0.2 minus 1 divided by 2 factorial. 2 factorial is 2. Del square y minus 1. Del square y minus 1 is 3. Plus P plus 1. P is 0.2 plus 1. If we add it, we get, directly I will making that addition as 1.2 into P 0.2 minus 1 del cube y minus 1 is minus 4 divided by 3 factorial. 3 factorial is 6. Next one is P plus 1. That value of P plus 1 is 1.2. 0.2 plus 1 we get 1.2. P is 0.2. P minus 1. 0.2 minus 1. 0.2 minus 2 divided by 4 factorial. 4 factorial is 24 into del raised to 4 y minus 2. That value is minus 9. Simplifying it further, 28 as it is, no change. 0.2 into 6 we get 1.2. Then this is 0.2. 0.2 minus 1 we get minus 0.8 into 3 divided by 2. That value is coming as minus 0.240 after simplification. Next plus, this is plus, minus and minus. Minus it become plus. Therefore final sign is plus. 1.2 multiplied by 0.2 into minus 0.8 into minus 4 divided by 6. That value is coming as 0.128. And lastly, this one is minus, this is minus, and again minus. 3 times minus, we get sign as minus. 1.2 multiplied by 0.2 into minus 0.8 into minus 1.8 into minus 9 and divided by 24. If you simplify it by calci, that value is coming as 0.130. And then taking the addition of all this, 28 plus 1.2 minus 0.240 plus 0.128 minus 0.130 as 28.95. And approximately that value we can round off to 29 lakhs. Therefore, population in the year 1992, which is in the center of the table or middle of the table, by Gauss's forward interpolation formula, we get that value as 29 lakhs. We cross check it whether true or not. For 1990 we have 28 lakhs. For 2000 it is 34 lakhs. 1992 lies between these two values. Therefore, the corresponding value must be in between 28 and 34. 29 is greater than 28 but less than 34. Means whatever the value we have, it is a correct one. Therefore, in this way we can use that Gauss's forward interpolation formula. In my next video, I will discuss this another type, Gauss's backward interpolation formula, and example on it. If you like videos, please share it as well as subscribe to my channel and press the bell icon to receive a notification of my new videos. Thank you.